Okay, let's get started. Today I want to walk through this handout I just gave you, 28 pages, and I think the idea behind this gives you an opportunity to see just what dairy comp can do. So somebody who's taken some time, dug in a little deeper, done some things that might not be intuitively obvious, but walking through that. When we start off this, or what we're using dairy comp for, are we using it to manage our dairy, or are we using it to evaluate someone else's? As a consultant, you might go in and you're going to look up different things. The emphasis on this paper, and that's on the front page, looks like I might have messed up some pages here. Has everybody got all 28 pages? You got a one on the front?
No.
Does anybody have an extra one in the back?
Oh, I have one in the back.
Okay. So I'm guessing somebody else has got a extra one in the back. So I guess there's some benefit to the fact that I couldn't staple them, but I was going on the title on the front. So you got an extra, somebody else is probably missing a one on the front.
Yeah, I am.
Hang on.
Oh, yeah.
Everybody else got all 28 pages. Hopefully I didn't screw up too bad. So you can see on the front, the emphasis on this particular article is I want to manage my farm and I want to do it in a timely fashion. So I'm looking for things that show trends. I'm looking for things that show how many animals are an exception to what I'm looking for. So we're not focusing on averages like we might from a consulting standpoint. We're not focusing on summaries. We're trying to dig down into a variety of areas. So I think they start out with production. We look at the bold titles. That goes on for a while. Then we get into reproduction. How is that going? The emphasis in this particular article keeps those separate. Udder health, how are we doing there? Disease rates, animals that are getting sick. What's a cow worth? How are my heifers doing is sort of what's in this article here. It's a little old, but I think most of the stuff holds up. So reviewing and monitoring herd performance with dairy comp. So we're going to play today with what can we learn or what can we find out with dairy comp. So this is getting beyond the basics. So the focus here on page 1, does everybody have this on page 1? Making sure we got it. So measuring current performance, err on the side of action, trying to find things that we need to do today so they don't become problems tomorrow. So, and then what we've just talked about, don't confuse monitoring the herd with describing a herd. We're trying to figure out, okay, what are the things I have to do? What are the things I have to figure out? What needs to be done on a given day? So that difference, what we're looking for is how could I put together a series of reports that'll show those red flags, show those animals that aren't behaving quite the way they should. What could we do today to prevent the appearance of problems in the past tomorrow? So talks a little bit about the theoretical nature of what we're trying to do. So we're looking for things that are giving us an answer or bringing out a problem as soon as it could happen. Preferably the first day that a problem begins. We're looking for things that reflect improved performance. Hopefully the first day it happens. And we'd like to track things that are going to make the herd more profitable, keep those animals around, show us where we as managers are screwing up, not providing the cows with what they need. So if you think about this, the example they gave, rather than measure when we got an animal first bred, let's focus on the animals that we need to breed today. So pulling up a list that animals that are more than 70 days in milk and have not yet been bred. So instead of worrying about the averages, let's find the animals that are messing things up. So that is an example. Is this possible? What he's looking for. The answer is no. You can't have perfect information immediately as it comes available, but you look at a lot of things that are presented, you're looking for trend lines. Are we going in the right way or are we going the wrong way? Trying to focus on things in the short term, near term. How are we going? So you can't know a problem, or at least most problems, until a little bit after. You're not going to know if you've improved things for a couple of days. So, but keep that in mind, what we're trying to achieve theoretically versus potentially. So they started out with production. So they start with this script up here. So what are we looking at here? We're going to sum. So we're taking a bunch of information and then we're going to put days in milk. Has anybody seen pea milk before? One of the underlying assumptions of this paper is that they are on DHI test. So milk is DHI number, so what might pea milk be? previous test day milk, whatever that should be. So in the back of this article, I think it's the last page, at least close to it. The last page, they bring in a lot of definitions of things they used. Most of those are on your lists already, but there's a few different ones. And then at the end here, you got 2.5 pages of all the different scripts they used for this. So MKDEV, what might that be? Milk deviation. So what we're doing with our cows, for each cow, we're projecting a lactation curve. So if we divide this up into test days, if everything's normal, if everything's as expected, if she's here this test day, she should be here next test day. So the question is, what did she get on that test day versus what was expected based on the shape of that curve? So milk deviation is where you're supposed to be minus what you actually did minus where you're supposed to be. So if we've got below, we get a negative number. If we're above, we get a positive number. So DDAT is what? What is that DDAT equals 0 doing for us? Anybody remember from last week? What kind of cows is that going to pull up? So you've got previous milk greater than 0, so we're at least the second test day in lactation. DDAT equals 0, animals that are not yet confirmed pregnant. So where are we focusing on? What are we trying to do here? Look at animals that are in early lactation with 2 test days. Are they doing what they're supposed to? So are we, for this area of the curve here, we'd hope they're bred by here. What's happening here? And then they add the Z with the \Z, brings the zeros into the average. If an animal is not producing milk or not recording milk on a particular test day, that needs to be included to make sure that we've accounted for all our animals. And if for whatever reason we don't have a weight on that date. So we've got doing this by pen. So pens 1, 2, 4, and 6. We've got number of animals that fit that criteria. Percentage of animals that fit that criteria. Number of animals that fit that criteria. Average days in milk. I think that's staying. And then average for the pen. Previous milk for all those animals. What is the current test day milk and what the difference might be. So what does this over here tell you? What does that minus 24 tell you? They're down a whole bunch, but how many animals is it? Just 1. So it's really not helpful from looking at a group perspective. But you have to ask why that cow is down. These here, plus or minus 1, we're not going to worry too much about. We seem to be doing well in pen 4. They're above what we'd expect their milk production to be. So they're generating a curve that's going to be higher. Another thing we might put together is a graph that helps us evaluate not just the group of animals, but what the individual animals are doing. And if you're managing a herd of animals, knowing who's above and who's below, there are some benefits. We tend to respond, you guys especially, your generation is a very visual generation. The ability to go through and click on all these individual cows, say, well, who's this cow down here? Or who's this cow down here? Oh, that's one, we had a DA surgery, that explains that. Or I have no idea why she's here. So we've got graph, that deviation of milk, that previous and current milk minus the expectation where they're supposed to be. So by fresh date and pen, so we've got fresh date going across the bottom here. When did they calve in? And then within the group, within each thing, we've got a different color for each group. So putting that fresh date and pen after the by gives us two different dimensions. We've got the fresh date running across the bottom, and then we got the different colors representing the pens, their animals in there. So what does this tell us? Milk greater than 0, fresh date greater than 0, due date equals 0. What does that do for us? Milking cows that are not yet bred. I think that's right. So you've got some sort of test day on them. They're calved in, but they're not bred again. We don't have a due date on them. So what's happening right over here? Animals that probably haven't been tested yet, but we don't have a number on them. So based on a previous lactation, we'd expect, or there's a prediction of what the animal's going to be next time around. And then when she comes in, is she performing like you'd expect or not? So where is she compared to what the curve based on her last lactation should be? This is also called TCI. Is anybody for a test? Transition Cow Index, TCI. It's put out of Wisconsin based on what the animals predicted. Is she positive or negative compared to what you were going to predict her to be? So what do we know about the animals above that line? So what is this line going across?
0.
0. So animals above the line are doing what? Better than expected or predicted. So they're doing better than expectations. These animals are doing worse than expectations. So why do we have so few animals over here? We've got all these fresh cows here. No test day, couple of test days. What's happening over here? Animals that are bred. We've lost them there, so they're not going to be plotted anymore. So you're trying to find out why this problem cows are down here. What's different about this group versus this group? So if you're looking at just the colors, what suggests there might be a problem. Where might there be a problem? Who's doing well by color? Yellow looks like they're doing better up here. Down here, we got a lot more green. Although you still got green on the top, but you've got, right there, you've got all greens. It seems like yellow and green, there might be a difference. When we're trying to figure things out, one of the first places to start is, what's the difference between the animals that are doing what I want them to versus the animals that are not? So we've got a pen difference here. I don't know, there's a days in milk difference or fresh days fresh difference, but we can look at that. We can start clicking on those individual squares and get those animals up and running. So this gives you an opportunity to see if our animals are doing better or worse than expected. What circumstances might lead to the animals doing better than expected? Being above this line over here.
Quality of feed.
Quality of feed. What else? We're going from calving in to the first few test days. In order for that animal to follow this curve, a lot of things have to go right. Feed. Calving. They don't have any problems at calving. Clinical or subclinical. So the animals that down here, below expectations, something bad probably happened to them. So what's the difference between these animals and the animals above the line? We know that the ones on the line are performing as expected. Their predicted curve is they're falling right on that line. Another thing we might do is look at test day averages. So we've got 3 lactation groups. We're plotting their test day milks, and this R here allows us to plot the test day or days in milk. So looking back over time, most recent, back here is a year ago or somewhere in there. What do we got for a timeline? 9, so about a year ago. So if we don't put this in here, we'll get lactation curves. One of the things that the author talks about is with lactation curves, you're grouping animals that calved in a year ago with animals that calved in last month. You're grouping everything by test day. And he says that he's not a big fan of that mixing of history versus current. I want to know what's going on now. So this information here, so we've got our first lactation group, second lactation group, third lactation group above for green up top. So that R allows us to avoid. So if we've got averages by lactation over the last year, what's happening in this graph? What's happening here? So how much milk have we lost? Every one of those cross lines is 2 pounds going horizontal. What have we lost in our green line? £6 to 8 pounds for that age group. Does everybody see that? You're up here, you drop down here, 6, 8. What's happening with our second lactation animals? We're not producing as much as we were. Same with our first lactation. We went up, we peaked around here, and now we're going back down. What might the reasons for that be? Is that a good thing? Question is that drop normal or abnormal? If we're falling down the lactation curve, we got a whole bunch of animals that peak over here, and then the herd is going down the lactation curve. We're moving up in average days in milk, then maybe that drop is normal. But we have to ask, why are we low here? Why were we high here? Why were we so low, relatively speaking, back here? We're drifting up. Is that a function of we're doing things better, or just the biology of the cow, or the season of the year, or the proportion of animals in different stages of lactation? So focusing on what's going on now as opposed to his objection to not including that \r would just give us standard lactation curve plots. So mature equivalent, 305 mature equivalent. What is that about? Does anybody know? It's a prediction that when this animal gets to her mature age, which is what? 2 lactations, so 4th or 5th or 6th lactation, this is how much, given that it's not too hot, not too cold, the forage nutrition is average for this farm, this is what we're going to predict that she's going to do later on. So if we're thinking about mature equivalent, we get to our more mature animals, the 3rd, 4th, 5th, 6th lactation, actual production should equal mature equivalent. With our first lactation animals, the red line there, what do we want our heifers to be compared to their parents? Higher. If we're doing genetic progress, we should have animals that are coming up that are higher. So this part of the curve back here, there's something not right with our first calf heifers. They're underperforming. This line should be always above that line. We're getting out here, things are sort of in the right order. You have to decide whether these production levels are where you'd expect them to be, or what your goals are on your farm. But this flip-flop back and forth certainly is a concern that we might want to look at. Is there something about our first calf heifers that at least a year ago they were underperforming? So we need to graph our mature equivalent by fresh state, by lactation group. And then for animals that greater than equals minus 365 is animals that are freshened in the last year. So we're looking at that mature equivalent projection on their first test day. Is that she's doing better calving in or worse than we'd expect? That becomes an indicator of how they're doing in our transition program. If they come in above their expectations, things went well. There were no problems calving, no problems right after calving. If they're coming in below, we usually can go back and say, well, she had this, she had that, the problems therein. So we're looking at that mature equivalent over the last year. So that fresh date or fresh date and that greater than going back a year. The BR includes both animals that are alive and dead. You can decide whether you want that or not. And then the R reverse it, or R in this case gives us a regression line. Everybody know what a regression line is? It's the trend of the data. If you do an average, a running average of all these things, in this case, that regression line, that blue line, is trending up. So over the last year, what could we say about our transition program? It seems to have improved. Again, with that data set, there's something about the yellow that seems to be pulling things up. Although that may not be mathematically correct, but it looks that way. So that regression line coming up, we've gained a few pounds of milk as in our mature equivalent. We're doing better than expected. So we're doing something right. We have an opportunity to check through. So this, instead of milk or mature equivalent, we're going to focus on fat. So our first test day fat. So by fresh date, we've got our both alive and dead, and the R gets that regression line. What's fat doing over the last year on our first test day? It's going down, but not much. What are the spacings there? So one block is 1 percentage point. So we're looking at maybe 1/3 of a percentage point. That might be noise given what the range is here. If animals give a lot of fat on their first test day, what does that usually indicate? Anybody know? If animals are putting out a lot of fat, it usually means they're pulling a whole lot of fat off their body. Usually is an indicator of ketosis. So these animals up here are in higher risk for ketosis. Down here, we start to get milk fat depression. If we've got animals that have acidosis on some level, that shuts down milk fat production, and we have lower amounts of fat in that first test day. So cleaning it up a little bit, percent fat, PCTF, by lactation group. I think he went through and did the backslash again to get what's happened over, oh no, this is by test day over the last year. So what do you have? Something's happening. If you compare these graphs, fat's going down, milk is going up. The question is, are they putting out the same amount of fat? We've got higher fats there, and then we're dropping again, comparing those to the lactation curve. Is it, we're going down the curve, so as we go down the milk curve, we come up on the fat curve? Or is there something about the diet that's causing that problem? So here we're graphing test day milk by days in milk and lactation groups. So we have days in milk for the herd, and then which lactation group are we dealing with? And what he's suggesting is that this is where we don't want any cows. Early lactation, low production. Those animals need to be identified and figure out what the problem is that put them there. So you'll have some animals early on that might be there, but by the second test day, they should be out of that square. And they don't come back down in that square until we get way over here. So you're looking for animals that, I think you used the word broke. Is that the text in there? Animals that were broke. I usually refer to them as train wrecks. Loser, boxed, not looser. It should be 1 O, not 2. Everybody see that? So animals that have had a problem, usually because we haven't managed them the way we should in the transition period. So early in lactation, not producing the way we'd like them to. The graph M average by days in milk for the last 30 days. So animals that have freshened in the last 30 days, so days in milk up to 30. Where are we? Which animals are up top? Which animals are down below? So what do you think the difference is with these two groups? What's the difference between what's up here and what's down here? First thing that jumps out at you is what? Up there, not what you got. Sorry, I didn't get your color copies. But they are available up on Blackboard. What do you have a lot of down here?
Red.
Red. Up here, what? Yellow. In this graph, remember the colors are going to change what they need from graph to graph. What does that mean? Yellow mean here? Looks like third lactation animals versus first lactation. Okay, my first lactation animals are not producing as much as my mature cows. I'd expect that. But is this too low as we move forward? So you have to decide that on your farm. So summarizing the animals, give me some averages. What are we looking at? So you've got 3 lactation groups, milk production for the last 7 days on farm, your current milk production, and then how is their average compared to what they're currently producing. Depending on where we are, especially if we're doing 30 days, we'd like this to be going up. So current milk should be higher. We're going up the curve than there. 2 points, 2 pounds. I might start to take a look at it. I'm not going to worry too much about plus or minus 1. There's a lot of noise. It's never a smooth curve. So plotting milk deviation, how we're doing, better or worse. What animals are we looking for? So days in milk, we hope after 2 weeks, things will start to take off. We'd like all those animals to be improving, not necessarily dropping, especially down in here. So you start to identify who's this animal, who's this one, why are they not performing the way we'd like them to? Is this that switchback? No. So you've got animals that for the less than 30 days in milk that have shown more than 6 pound deviation or 6 pound drop in the last day or so. So you've got the average for the milk, what they're currently producing. What kind of differences do we have? So if you looked at, ran this report a couple weeks ago up at the dairy, we're switching corn silages. Almost a third of the herd was on that dropping milk production report, or low milk production in the last 24 hours report. That transition was a little bit rougher than we wanted it to be, but we seem to have gone through it. There's another thing that you might want to deal with if you want to break your lactation into different parts. Maybe out 200 days, 6 pounds. Well, that's just what happens. You're a little bit more focused on your early lactation animals, not too much on your late lactation animals. So we're able to, with this syntax up here, to create 3 groups of animals. Early lactation that have dropped 6 pounds, middle lactation that have dropped 9 pounds, and late lactation that have dropped 15. We're focusing on our first lactation animals, the ones that are down. There's a chance to correct things. The noise in later lactation, we're going to let go. So looking at events, we got event day, what's happening, how much those animals are producing, going through and maybe pulling out a couple of animals that we want to take a further look at. These are fresh cows. If nothing else, it gives a list of things that have happened. Hopefully this is all fresh. If we start seeing other things, more recent things, problems, we're in trouble. So reproduction. If we take breed sum and we put in the \E, it gives us our 21-day risk of pregnancy. So here's the start of each 21-day cycle going back in time as we go up. So how many animals were eligible during that period? How many showed heats? How many were bred? Heat and bred might be the same thing. How many were eligible for pregnancy? How many pregnancies actually occurred? And then we get over to our percent preg rate on this side. 16 is the average for this herd over recent months. Is that something we want to shoot for? No, we need to be up in the 20s. We need at least 10 points higher. So looking at this chart, what do you think the problem is? Might be heat detection. So if this many were eligible and this many were showed a heat or were bred, our heat detection is pretty low. So we want to get on top of that. We might be doing a little bit better down here, but the trend doesn't really show that we're improving. We have our range around, that's 14%. That might be our high number. That might be our low number. Probably easiest to focus just on the averages. We add some things that I hadn't seen before to our breed sum. We've got our E in there to give us our 21-day periods instead of doing technician or doing day of the week or anything like that. E runs a 21-day heat trial. And D 150 restricts it to the last 150 days. So we're not looking at information too far back. We've shortened this up. What are we doing? We know over the last year it's been 16, but over the last half a year, we've gone in the wrong direction. Although that may be a sampling, we certainly haven't improved. 16 and 14 might be the same statistically, but if you go down after you've created these reports, sometimes a graph can be generated with that. If you're more interested in how things would look, we go from the report over to the graph tab and look at things more graphically. So over the last year, heat detection rate as a percent. We need this up around where to really get into the 20s. Everybody remember what's a reasonable, good conception rate? Let's say 40%. In order to get something greater than 20% for a preg rate, what does my heat detection rate have to be? Get at least 20, what do I need?
65.
To get at least, we need at least 50. If we want to get up in the mid 20s, we need a 60%. 60 times 40 is going to give us 24. If we want to get in the high 20s, we need to be up around 70. Where are we in this diagram? The highest month we have is a little over 65. So if you look at an average, you're probably down around here, which is less than 50%. So that goes back to looking at that other diagram. It becomes very obvious here that we've got some work to do. So heat detection rate, that's probably where we got to figure out what we're doing. So plot last 300 days. Animals that were bred on a specific day, what happened to them? So what do we have over here? Animals that have not been confirmed pregnant yet, right? So it's unknown where they are as we work our way through. By days in milk, what day of milk they were. So we got all breedings here. So you're going to have animals that are going to work their way up the chart as you move through. Have they conceived? What are they doing? What part of the year is not quite as good? So taking a look at that. So this is a graph over the last 200 days that allows us to sense how much time breeding versus heat detection has occurred, the results, breeding off time. So you're plotting everything by day, which animals are getting pregnant, which ones are not. Those spikes are usually sync days. So I find this graph a little hard to read, but it's an opportunity to learn some more nomenclature there. So animals that we need to breed or get bred soon, greater than 70 days, no breedings, rack code greater than 1. Rack code of 1 is what? Do not breed. So what happens if we have a bull in our dairy comp? Rack code does not equal 1, or it's greater than 1. Bull is where? At the other end of the spectrum at 9. So if we do have bulls in our herd, in our dairy comp, they're going to show up on this list as well. We'd probably have to do not equal 1 and not equal 9. Herd snapshot. How many animals are in the herd? And then what group or category are they in? So we've got our dry cows down here. You got your heifers and your milking cows. So you've got almost a 1-to-1 relationship. Most farms have said we can't afford to carry that many animals. So those heifers, at least in New York, have dropped down to about 85% of the lactating herd. So, but here we're dealing 1-to-1, and that may be a function of back. This is an older paper. Udder health. So plot linear score by lactation group over the last year. That R gives us the last year. So how are we doing in udder health in this herd on average on test days? Any problems? What linear score is a problem? Anybody remember? Greater than 4. Where are we on this diagram? So up to 3, this line up here is 3. Going across. So on average, we're doing pretty well. So over the last year, what has our linear score done? One of the things you're going to find that in certain areas of the country, there might be different codes for different things. I think they might have combined that together, but log 1 versus LS1, linear score 1, log of lactate or somatic cell 1. So we're looking over the last year, what's happened to our somatic cell. Creeped up just a little bit with our regression line there, but we're still not a problem. We're still under 4. We've got a group of animals up here that we have to ask on their first test day, what was the problem? She's almost a 9, more than an 8. These two right there, why did they come in so high in somatic cell? We can graph the same thing. I really don't fully understand the nomenclature here. It's very detailed in where your linear score categories are and which ones you're going to do. So you've got your graph tab. This makes a little bit more sense to me. You've got all these different categories for mastitis, chronic, new infections, cured, clean animals, percent high fresh cows, percent low fresh cows. Should add up, but I'm not seeing that. So chronic is what? You got 2 test days in a row where she's above a 4. New infection, she spiked to 4 on the most current test day. Cured, she dropped from a 4 down below a 4 on the current test day. Then clean, you've got 2 test days in a row below 4. So we're looking at what's happened over the last year of test days, 13 months. How are our chronic infections versus new infections? This is a graph. I'm out of time here. What do we got left? There's some other things to talk about. So we'll stop here with udder health. You can remember, bring that, was this useful to you?
Yes.
So we're trying to show you what this program could do. We're going to get your own copy of the program after break, and you're going to be able to start doing some of this stuff. So bring this paper next class. And we'll talk about some of the other things that this person, I don't know who the author was, suggested that be done.